Good morning to everyone. Um, in the previous class, we were discussing about the different sampling techniques, how to do the sampling, uh, what are its importance in during the sewage treatment or uh, in sewer distribution network. So we have discussed uh, the grab sampling. Of course, so there are three types of sampling techniques. One is grab sampling, and one more is uh, integrated sampling. Third one is composite sampling. So, integrated sampling means grab sampling means uh, collection of the samples at a uh, single spot at a single time. If you take it the spot 1 as S1, spot 2 as S2, so then S1 sampling collections assume we'll see in this way. Assume that we have S1, of course, the sampling spot 1, we are collecting at 9 a.m. Then S2, then you collect it at 10 a.m. Means the sample at all the locations at different times. So then composite samples should uh, provide a more representative samples of heterogeneous matrices in which the concentration of analytics of interest may vary over a short period of time or space. So composite sample can be obtained by combining the portions of multiple grab samples or using specially designed automatic sampling devices. So composite sampling means is very simple. We can take S1, S2, S3 are spots. You can collect all these at a time. So we have these are composite samples collected at a single time. So composite samples are collected by using continuous constant sampling pumping or by mixing equal volume collected at regular time intervals. So this is what your composite sample is. So then integrated, that is a discharge weighted samples. For certain purposes, the information needed is best provided by analyzing the mixtures of grab samples collected from the different points simultaneously or as nearly so as possible using discharge weighted methods such as equal width increment or equal discharge increment procedures and equipments. So an example of needed for integrated sample occurs in a river or a stream that varies in composition across its width and depth. To evaluate the average composition or the loading, so use a mixture of samples representing various points in a cross sections in a proportions to their relative flows. So integrated sampling means it is a discharge weight, and they have discussed in the paragraph. It is said that, for example, you have a river section will be there. So assume that consider these 3 points. Here also other side consider these points. So wherever the discharge as well as the depth are constant, there only you have to collect all these sampling. So assume that this is S1, S2, S3, S4, S5, and S6. So means at this point also the discharge should be same. This point also discharge should be same. This point also discharge should be Same. So if that is the case, so then we will uh, go ahead with the equal depth formula as well as equal discharge formula. Suppose if you are not getting at least near to that depth, you have to consider it and you have to take the samples. So if this kind of samples, if you are considering, we can call it as integrated sampling. So then sampling methods. So the manual sampling is there and some of the equipments are there to do the automatic sampling. So manual sampling involves the minimum equipment, but it is costly as well as the time consuming for routine or large scale sampling programs. So it requires trained field technicians and is often necessary for the regulatory as well as the research investigations for which the critical appraisal of field condition and complex collection systems techniques are essential. Of course, these are not that much accurate. Some of the research investigations, if you are doing it, um, least it will be preferred. Um, of course, in some parametric analysis that we'll discuss how exactly these parametric analysis are different than manual as well as automatic samples. Sometimes the manual sampling is more accurate with some aspects. Um, in some places, it is not that much accurate. So, of course, we have to study the each parametric analysis, how exactly the sampling has to be conducted um, for example, chloride. Assume that you have chloride if you are going for chloride test. So, how exactly the sampling has to be conducted? Suppose if you are doing the sampling analysis in most of the sewer network, if you are interested in finding the solids, we will come back. What are those solids and chlorides? Then what kind of techniques are feasible? That also we have to see. So normally this manual sampling um, requires uh, some proper technicians to do the sampling, and you should know the variation in the different parameters that are involved in the sampling. So then automatic sampling, automatic samplers can be eliminated the human errors. Of course, there's only one advantage, eliminated the human errors. Uh, and it will reduce the labor cost also. That is the biggest thing. And it may provide the means for more frequent sampling. For example, um, manual sampling, what will happen is that if you go for more than 100 sampling or 200 samplings, you will stop doing the sampling for each days. So if automatic samplers are there, it may not be any problem. You can do it 200, 300. There will not be any problem with the labors as well as, and it will be like that much accurate only, and are used increasingly. Sometimes what will happen is this is the biggest problem in the automatic samplers. So this is what if I say the automatic samplers, this is the biggest problem. It does not have to contaminate the sample. See, what will happen is that you may think that the automatic samplers will take the sampling up to some depth, but sometimes if you increase the depth of the sampling, sometimes it will work on the principle of suction. Um, Suppose if it is taking from the bottom portion, then you may not get the exact quality of the uh, wastewater or the water which you are sampling it. So it is better to go for the automatic samplers based on the requirements. Don't go for all types of samplings directly for automatic samples. Sometimes uh, it may not be feasible. So then we'll move on to the wastewater characteristics. Of course, the wastewater is simply that part of water supply to the community or to the industry which has been used for different purposes and has been mixed with solids, either suspended or dissolved. So there are when it comes to some of the solids, we'll discuss in detail what are its classifications. Normally, we'll classify the solids like suspended, suspended, dissolved, and colloidal. So normally, uh, solids are means, for example, silt, sand, comes under one category. For example, if you take salt, if you dissolve it in water, that is also one solid, but it is dissolved. Colloidal means if you take a chalk powder and if you dissolve it in, or we can say it is milk particles. If you take the milk, um, if you find out what kind of solids are there in the milk, there comes under category of colloidal solids. Whatever the wastewater, always it consists of 99.9% water and 1.1% of solids. The main task in treating the wastewater is simply to remove the most of all this 0.1% of the solids. Solids, either it will be suspended or dissolved or it will be colloided. So then, which are the types of wastewater from the households normally will get it? So we are going to classify the main three things for type of wastewater. These are things. There is the first one, the grey water. If I say it is a grey water, it is washing water from the kitchen, bathroom, and laundries. It does not contain any fecal matter as well as the urine. Means um, the toilets it won't consider. Only from the kitchen, bathroom, and laundry. If it is coming, then normally that water we can call it as grey water. Black water, water from the flush toilets. That is black water. Uh, the feces and urine with the fresh water, that can be considered as a black water. Yellow water, urine from the separated toilets and urinals. That is brown water, black water without urine, or yellow water. So these are typical some of the things normally we will use it whenever we are using some of the wastewater characteristics. Sometimes if I say grey water, you should know what are its sources. If I say it's a black water, you should know from where it is coming. If I say it is yellow water, uh, what kind of its characteristics. Then brown water, it is the black water without urine or yellow water. So like that, different types of characteristics we will use it, and different types of wastewater we will name it based on the its usage. So all we require, whatever the gray water, black water, yellow water. Sometimes when it comes to the sewage, if I say it is sewage, um, it is all gray plus black water plus yellow plus brown water. So sewage consists of all. There is no such like separation of the only urine or the whatever uh, the toilets. So then we are going to classify all these characteristics, wastewater characteristics into three. First one is physical, physical characteristics. Then second one is chemical. Third one is biological characteristics. So this all these characteristics we will discuss in the next class.